So this morning we've heard about the advancements Appian has made with data window technology, bringing that to a .NET and an API world. We've seen sort of rapid development of APIs with scaffolding and automatic conversion tools. You've heard from various of our customers that have gone through porting some of their business logic over from PowerScript into C# so that they do have API enabled and cloud architecture. Now, what we're very excited to share with you now is something new for 2019 R2 called the PowerScript Migrator. And what that does is accelerates the migration of your business logic to C#. So our customers have been successful even without this, but with automatic conversion of your PowerScript business logic to C#, we hope more customers will be making the move to an API architecture as well as benefiting from the .NET ecosystem. So before we start talking about what the PowerScript Migrator is able to do for your projects and how much it'll accelerate, I think it's important to understand what was Appeon's philosophy towards C# migration, because that dictated how we designed this solution and specifically the result it provides. It was all driven by our philosophy. So our top consideration in helping you move to C# is to ensure you comply with standards and ensure maintainability to migrated C# code. It's fine and dandy if someone can migrate you overnight, but if the result is garbage, what's the point? So we're accelerating basically as much as possible without compromising standards or the maintainability. So what does that manifest itself as? For example, if you take a look, we're not doing like a bulk conversion. We have you intimately involved in the conversion or migration process where you're taking function by function PowerScript code and migrating that or converting that to C#. As another example, when we are mapping the PowerScript statements to C#, we're doing so using standard C# statements. We're really trying to minimize any sort of dependency on libraries or anything non-standard proprietary. And when it comes to PowerBuilder features, again, we do our best to find something as close as possible that the .NET framework itself provides, again, so that you have the most standard application possible with the least reliance on any sort of additional libraries besides the .NET framework itself. Now, also, our converting tool is pretty smart. We want to adjust to the .NET way of doing things. So, for example, indexes in .NET start from 0. Now, in PowerScript, it starts from 1. And we could have obviously started it from 1 in C#, but that wouldn't be providing a good best practice and maintainability in C#, so we don't do that. Now, that's just one example of us adjusting to sort of .NET way of doing things. Now, there are some things that .NET just doesn't do that PowerBuilder does in PowerScript. And so we've really carefully weighed this out to see what things Appion should provide in a bridge library to take care of the C# gap. Now, we're not bridging everything that PowerScript does that .NET doesn't do, again, because anytime we're doing something, we want to make sure that we're following standards and ensuring maintainability. But we've tried to strike a good balance in terms of bridging that gap enough so that you get acceleration of your migration without compromising the project's integrity. So with that philosophy in mind, we've designed a number of components that I'm going to go over for this migration solution. It's basically a combination of tools and libraries that accelerate the migration of the PowerScript business logic into C#, as well as REST APIs. That probably be the use case most likely if you're going to be modernizing your business logic. You generally want to API enable it, not just go to C#. So we're including the PowerScript Migrator solution inside of the Universal Edition starting with 2019 R2. So that's the highest tier of the PowerBuilder subscriptions, and if you get into the highest tier, you're going to have everything, including this, and it's a huge cost savings in terms of compared to a rewrite. So this pays itself up and then some. Now, the tooling is built on top of the Snap Develop IDE, so that is required, and the Snap Develop IDE is included in all editions of PowerBuilder. But the PowerScript Migrator is a plugin on top of that because it's it's doing the conversion to C#, so we need a C# IDE. Now, the conversion requires a data window converter plugin because when we're moving your PowerScript to C#, that PowerScript obviously is using the data window, and so if your data windows aren't converted over to C#, then obviously the converted code is not going to run. And so you will need a data window converter plugin, and that's included with the Cloud Edition or higher. So you already have that even if you're not in the Universal Edition, and our solution requires that. Now, the data window converter plugin, just to remind you, also consists of the .NET Data Store, which is a library on NuGet by the name of dwnet.data. Now, the PowerScript Migrator plugin is going to be leveraging the Snap Develop IDE and the .NET Data Store and the data window converter plugin. And the PowerScript Migrator will be reading your PowerScript function by function and generating as best practice as it can the C# corresponding to that. And also there's a C# bridge library. Now, it's not 100% required. It really depends on what PowerBuilder features you're using, and I'll be talking about that in a minute. But certain PowerBuilder features will require you to use the PowerScript.bridge, that's the library name on NuGet, to take care of bridging that C# gap. In our experience, probably most applications will require it because they'll be somewhere small in the application where they did use one of these features that requires the bridge library. So let's talk a little more about the PowerScript Migrator plugin in more detail. It's a C# code converter for the business logic. It's going to convert PowerScript to C#. It's going to take embedded SQL over into your C# project. It's also going to handle data window data store APIs. So when you've written PowerScript to reference the data window or data store, for example, like a data window.retrieve or a data window.update, it's going to take care of converting that over to C#. Now, let's talk about that bridge library. As I said, it's not 100% required, but practically speaking, there might be some small place you might be using something that requires this library to bridge that gap. So we really try to minimize the dependency on this library and only use it when absolutely necessary. When it comes to blob data types in PB, we really couldn't map that over to .NET, and we have come up with a PB blob data type that's included in this bridge library, which basically emulates the way blobs work in PB, and we feel we've done this in a standard way without compromising the maintainability of your project. Now, C# doesn't do unbounded arrays. That PowerBuilder does. C# doesn't. C# you're limited to bounded arrays, either single or multi-dimensional bounded arrays. So for unbounded array, if you're using this in your application, you must use that library, or you're going to have to go through all that effort and cost and potentially risk to rewrite your code to work in a way that's not using unbounded array. So we feel that it's worthwhile to use a bridge library for that. There's going to be certain system functions that we were not able to map to standard .NET system functions that were very PB specific, and so we provided some of those system functions in a standard way. Now, the .NET Data Store originally was designed for rapid development of APIs, doing new development. We had not considered migration, and so in the bridge library, we have added some functionality that generally, you wouldn't use necessarily if you're developing a new API with data windows from scratch. But if you have existing business logic and it's relying on some of these features of the PowerScript data store that the .NET Data Store doesn't currently support, These data store extensions bring that to your migration project so you don't have to rewrite those functionalities in your code. Now, embedded SQL can be mapped into standard C#, but there are specific types of embedded SQL that require the bridge library, specifically if you're using cursor, stored procedure, or dynamic SQL. So if your embedded SQL is just standard embedded SQL, it's not dynamic or not stored procedure or cursor, then you don't need the bridge library. So now, keep in mind, our philosophy wasn't about doing 100%. It was about striking a balance, accelerating the business logic conversion while producing a good result. So we're never going to go to 100% no matter how long we work on this, because reaching 100% will require us to compromise our philosophy, which we don't think is the right solution. So that's not something we're going to endorse or release to the market. Now, with that said, even sticking to sort of our noble philosophy of trying to do what's best for your project, we have delivered a high percentage of conversion. Now, these percentages are not based on customer feedback because this solution hasn't even been released to market yet. But internally inside Appeon, we have a number of customers that have submitted their real-world applications for our testing purposes to help move the product forward. And in using some of those examples, we've done internal testing, achieved this sort of result. So, your mileage may vary, but we think you should be able to achieve at least 90% automatic conversion of PowerScript syntax. So again, keep in mind we're doing non-visual business logic, not PowerScript manipulating a user interface control or so on. But anything non-visual, including all the different data types, not just the primitive data types, but complex data types, you should be able to get 90% conversion of that syntax. Now, when it comes to system functions, again, non-visual only, put that disclaimer out, we're going to be roughly between what the bridge library provides and what the .NET framework provides itself. We can roughly, I think, get about 75%. Embedded SQL, it should at least be 90%. In fact, I think it should be 100, and we think we can work on enhancing the scenarios that the converter is not handling yet to reach 100% for embedded SQL without compromising the code quality. Now, when it comes with data window APIs, again, we're talking about non-visual, so because we're mapping to the .NET data store, between the extensions of the data window APIs provided in the bridge library plus what the .NET data store provides as well, we should be able to map, I would guess, at least 80%, if not more. If you define structures, we should be able to convert 90%. And now, if you've been following the old best practices of PowerBuilder from back in the day, which said that you should logically separate your business logic into 3 tiers instead of having all that business logic intermingled with your user interface, then we can also take care of migrating the actual MVO skeleton for you as well. If you want to do that. Now, if your business logic is in the user interface, then you probably won't need to take advantage of that MVO migration. But that's also something that is able to be automated, and we can achieve 100% automation on the MVO skeleton or shell itself. So I'm going to turn it over to Govinda now, who's going to walk you through a lot of different code examples and show you how this stuff is not just a demo, but it can handle real-life applications that you would have, because at Appeon we did test it with real-life applications, and we want to put forward to market something that really works. So Govinda, please take it away.
Thank you, Armeen. Okay, so now let's take a look into the C# migration solution for the next release. So in this case, I have the workspace of a PowerBuilder project right in here, and you'll notice that in here I already have some non-visual objects already set up for me. Now let's take a closer look first of all into how this solution would automatically translate the data types from PowerScript into C#. So I'll double click right here. Okay, so now this opened the PowerScript for me. So here I will see the functions inside of this PowerScript NVO, and if I right click inside of this function, I'll get to menu options. One of them is translate and copy to clipboard, and the next one is translate and open in editor. So I'll click that one. Now I get a window that's actually having translated all my PowerScript into C#. So let's take a look into the data types. These are the standard data types. So we have integer, you get it translated to short. You have a long, it translated to an integer in C#. Des is actually a decimal. Real would be a float. Double is a double. Unsigned integer is a U short. Long is a long. Byte, it's a byte. Boolean is actually a bool. We have the string, the char. So if you notice right here, we have this question mark, right? That means that it's also accepting nulls. But look, this is actually smart enough to find this type of cases. So you notice right here that we have a date variable declared in here, and in that variable we're actually already assigning a specific format for the date for this variable. So if I see on the C# translation, then you'll see that it's actually already assigning the date and the format for me. See, it's year, month, and date, accepting also nulls, and similar case for the time right here. So let's take a look at the next standard data types. So I'll click right here and see the blobs. Now the blobs is a different case. That is because the blobs don't behave the same as they do in C#. So for that reason, we had to add a new type that is called the PB blob. Now the PB blob comes with a new library called PowerScript.bridge, and this library is for those cases that there are certain data types and or maybe global functions or system functions that are not found in C#. So this is actually enabling you to continue using what you had previously on PowerScript, but with the new objects. Everything else, which is the most of it, is actually standard C# code. It's generic. You don't need to be modifying too much or having to do other different types of solutions for this to work. So let's see, this is the PB blob. Let's take a look at some other examples of some other data types. Now we will continue with the arrays. Now you'll see right here, if I click in here, see right here you have array, and this is a bounded array. It's one-dimensional array right here. We have another bounded array, and this is a two-dimensional array. And notice how this translator is actually smart enough to see that PowerScript is asking this values to be set up like this, but in C# it's actually different. This is done for you. You don't need to make any changes unless you wish to. So then notice that we also have in PowerBuilder what we call the unbounded arrays, but this is actually not available in C#. All arrays need to be bounded in C#. So we have added the PB array object. This object in C# is also found on the PowerScript.bridge library, and it also supports bounded and unbounded arrays as well in C#, so that you can use it with any other generic or standard C# code. So let's take a look at the next one. See the type any. Let's look at this, how it gets translated into an object right in here. See? Okay, now let's look at the next one in here, the structures. Now structures, if I click right here, translate and open in editor, you'll see that the structures are being declared and set up as null, and then I can start adding values inside of the structures that I might need. But the structures behave a little bit differently in C#, and that is because in C# a structure needs to be composed of only standard data types. So this one right here, if I double click on it, you'll see that this is the definition of my structure in PowerScript. But if I click right here, I'll say translate and open in editor, you'll see that it actually translated into a class, and that is because this is actually not a standard structure for C#. This has actually been smartly translated into a class because it has some very specific non-standard objects inside of the class and data types inside of it. But if I actually wanted to do this the PowerBuilder way, the PowerScript way, I can retranslate it and set it up as a structure, as you can see right here. Notice how this is also automatically adding some comments for you, some things that you might need to look into. This is added for you by the translator so that you can take a closer look into something that might be missing your translation. So let's continue with the data types. We have the enumerated data types right here. So for example, the data window status, the data window item status, and see how this actually got translated, and any comments, anything that I might need is already placed in here. So that is the basic translation of the data types, but we mainly have 3 different PowerScript that we want to translate. So the first one is the basic syntax, we have the data store syntax, and we have the embedded SQL. So let's take a look at the first one. So on the basic syntax, let's scroll down a little bit over here. So the first one is the loop. Let's take a look at the loops inside of C#. Notice right here how we have a for next loop in PowerScript, and this for next loop right in here is actually doing a count, but PowerBuilder indexes normally begin on 1, and that is automatic. But for C#, the indexes begin by 0. So you see how this is set up as 1, and it automatically translated this correctly into a 0. So this is done very smartly and in a smart fashion for you, and in a standard way as well. So if we continue, we can look into the do while loops right here. We have the loop while, we have the do until, we have the loop until, and everything else that we might need on these loops. So let's take a look into the if conditions. Now if I click right here, let's see how this works. Notice how this if is also accepting the else if and the else. Here we go. And we have a traditional choose case. It's translating this into a switch case. But there's something very nice in PowerScript, and that is that we can use this type of syntax. For example, is greater than 100. Now this is not something very traditionally done in C#, but it's a nice feature from PowerBuilder and PowerScript. So if we look right here, this has actually been done automatically and in a very smart way for me. So this is all pure C# standard generics language, and this doesn't need anything else to function properly. And this is done for me in a right way. So let's continue with the next one over here. So we have the create method and the create right in here. Notice how we're actually creating a new object right here. It's been replaced by the new. Now what if we had the dynamic creation of objects? We have create using the object, and this is smart enough to actually be telling it that you can create an instance, but you need to get the type of the instance in C#, and this is done automatically as well. So let me close this and continue with the next one. Now let's see how we call the functions and events from PowerScript and into C#. So in PowerScript we call event and the name of the event. This is the way in C#. This is a post event right in here. We have and posting another event right in here. The dynamic calling of an event, etc. So let's continue with the next one over here, the try catch. Now the try catch syntax is very similar from PowerScript to C#, and you'll notice that we have the try, we have the catch as well as in C# and PowerScript. We have the finally, we have the exception, and we have it right as well in here. So this is translated very directly. Now let's take a look at the global functions or the system functions from PowerScript. So if we click right here, you'll notice that we have the string now, and this is automatically done for me as well with the standard format that is required. So that takes care of all the standard or basic PowerScript syntax. Now let's take a look at the data store syntax. Now some of you might already be very familiar with this because this is basically the same as you have from PowerBuilder or from PowerScript. You'll get it translated into C#. So let me click right here, and you'll notice that we have already created the data store right in here. We have assigned the data object, assigned the set transaction object, which is data context in this case in C#. We're adding rows by doing a full CRUD in here. We're doing the create, we're doing the read, here's the update, here's the delete. Okay, so let's continue for the next data store syntax. Now accessing data in the data store, if I right click in here, see how we're actually again creating the data store, assigning the data object, transaction object, and doing finally the retrieve in here. Okay, so then we're getting an item number, but this is smart enough to see that it's getting item and parsing it is in integer accepting nulls, and this is done automatically as well. So let's continue to the next example. This is accessing data window properties. So if I right click in here, seeing how we're actually going into the data window column count property. Here we have it, data window column count in C# as well. This got translated for me as well. So let's continue with other data manipulation techniques, and we can see that we have the find, the sort, the filter, row discard, rows move, and reset. So if we look into the find, see how the find is here. This is a find, and this would be a find index. Then we have a sort right in here. Then we have a filter in here. The rows discard is delete row, rows discard. There you go. Rows move, etc. And then finally the reset right here. Let's take another look at the next one, retrieving drop down data window. So if I right click in here, and you'll see how this is automatically doing the get child and doing the data context as you would normally in PowerScript, right? As you can see right here, the retrieving the drop down data window as well. So that takes care of the data store syntax. But what about the embedded SQL? Now we have two types of embedded SQL. So let's take a look at the first one. Now we have the traditionally embedded SQL. This is an example of doing a CRUD with embedded SQL. Now notice in here how we have the create. So this is doing the insert. It's translated into a string variable, and this is doing it automatically in a very smart way because it's actually doing one of the following commands in here, or the SQL statements, and it's actually already putting it into separate positions inside of the PowerScript. So in here you'll see that it's actually doing execute non-query, so it's using the SQL executor. But then again, this is pure C#, and this is so easy and so generic that you can use this with whatever other web APIs or whatever other C# DLLs that you might require as well. So notice how this is actually catching out the result, passing in the arguments as well. Now let's take a look at the read. See how this is actually retrieving one column right here, one row. So this is smart enough to see that I am actually doing only one of them, so I'll call the scalar method of the SQL executor. So this is important because the scalar method would only retrieve the first column of the first row from the result set. This improves and enhances performance from within the PowerScript or the C# to the database call. Now let's take a look if we were retrieving multiple columns and only one row. So in this case it would only be doing a select one. This select one would only be retrieving the first row of whatever SQL query I have in here. Now for the update, Notice how this is executing non-query, and for the delete as well. So now let's take a look at other transaction management with the commit and rollback with embedded SQL. So this is managed basically the same as you do with the .NET Data Store. You see how it's doing the rollback. Here's the rollback using SQL CA. This is the context, and committing with the SQL CA as well. So let's take another look into the blobs, selecting blobs. Now if I click right here, you'll see that I am actually doing a select blob in here. So this is select blob, large photo. It gets translated automatically to the corresponding methods inside of it. So this is also doing the update to the blob. Now let's take a look at the procedures. How do we call procedures and execute a procedure from an embedded SQL procedure? So let's click right here. You'll notice in here, first of all, that we need to declare the SQL procedure and setting all the parameters it might require as well. So in here, we're going to be doing the same. We're executing the procedure, but first of all, we're going to name it and catching the out variable, setting up the new parameters with its data type right in here, and then we're actually going to be fetching it. So executing it is, as you can see right here, execute procedure, and then fetching it as we do in PowerScript is also available right here by doing the next. And you'll see that we're fetching the values into variables, so we're doing the same right in here. Now we're going to do a loop while to fetch each one of the values from my procedure. This is done as well in C# automatically for me, and then we're going to be closing the procedure as you can see right here. So let's continue with the next example, and this is for the cursors for embedded SQL. Now if I click in here, you'll see that first of all it's going to be declaring the cursor. So this is actually going to be setting up the query for this, as you can see in here. Now notice that in PowerScript I'm using this character right here, but in here I'm using this other one right here. So this translator tool is smart enough to know what database you are using, so it would set up the correct character for you for this, for your queries. So then after this gets already set up, then it's going to be executing the cursor by catching out the response and passing in any parameter that it might require, as well as you would in here. Then we're going to be doing the fetch into, that is done in here, getting the values and fetching everything else inside a do while loop. Here you go. Finally, we're going to close the cursor. Here it is. So this is done all instantaneously and automatically for me, but we are still missing another type of SQL. Now this is dynamic SQL, this is embedded dynamic SQL. Now we have 4 formats of embedded dynamic SQL, and this translator tool is capable of managing all of the formats. So let's look into the first format. You see right here that this format is actually has no result set and it has no input parameters, right? So this is actually doing an insert into with the values. So it's going to be setting up the query in here, executing the query as you can see right here using the data context or the SQL CA, and that is one example. Now deleting a row, you can also see it right here, executing it and returning. So that's the first format. This is already compatible with the translator tool. Now let's take a look at the second format. Now the second format of the dynamic SQL is in the case that you have no result set statements and you have input parameters. So in this case we have an insert into and we have some values that we want to pass in. So this is actually doing the staging area for me. You see, prepare SQL SA. So this is doing it automatically for me as well in here. I'm going to set up the parameters. This is all placed on here before, and I'm going to be passing in the values and executing the SQL CA. So notice how this is actually executing it for me, catching the result, passing in the parameters. Now this is also being done for the deletion right in here. Okay, so that takes care of the format number 2 of embedded SQL. Let's now take a look at the format number 3. Now on this format, if I click right in here, you'll see that in here it is based on result set statements in which the input parameters and the result set columns are both known at compile time. So in this case, I'm doing a select from a certain table. I'm creating the SQL context, passing in the parameters, executing the cursor right in here, fetching the values as we would normally do by opening the dynamic cursor and then fetching in the values. Once we get the values, we can now close it as well as we would in PowerScript. So this did it automatically for me. Now that's a case that we might be wanting to use a cursor for this dynamic SQL, but what if it were a procedure? So this would automatically do it for me as well. It's going to be executing the procedure. Here you see, creating the context, putting in the parameters, executing the procedure, catching the result sets, and as well as the passing in the parameters that it might require. Then this would automatically be fetching the next values into the variables that might be needing it. At the end, we would close the procedure, as you can see right here. So this is doing it very smart for me, and everything is done in a very standard generic C# way. Now let's take a look at the fourth format of embedded SQL. Now in this format, you can see we have result set statements in which the input parameters and the result set columns are both unknown at compile time. So this is the most extensive example of what we can have for embedded dynamic SQL. Now this is also doing the execution of one of these procedures. You can see it's using the staging area. So it's actually creating it first, then going to be doing the create SQL context right in here, and then passing in any value, setting up the parameters as you can see right here, executing the cursor, fetching the values, using a choose case for this, then closing the procedure, and doing an if I needed to. So this is automatically being handled for me. So as you notice, this was a very smart conversion tool. It's an automatic PowerScript to C# translation tool that is doing most of the work for me. Okay, thank you, Armeen. This is what I got for this session. I'll send it back to you.
Wow, that was a lot of code Govinda showed us. Thanks for your patience. It was important for us to go through all of that just so you could get a better sense of the breadth and depth of what the PowerScript Migrator can handle and how it does its conversion. And I just want to briefly recap, give you a big picture view of what you saw. Again, not to sound like a broken record, but what you're seeing is complying with standards with an emphasis on maintainability. And I think a few key characteristics to make sure you're aware of is that this migrated code can be easily maintained by either PB or .NET developers. It's standard C# code, so it should be no problem for a .NET developer. And for PB developers, the code is utilizing data window technology. So even though it's C#, it should not be so foreign for a PowerBuilder developer to maintain. Now, again, we're following standards, and there's no dependency on any tooling set. So yes, snap develop is required to do the conversion, but once the code is converted to C#, you don't have to continue using snap develop if you don't feel that's the most productive tool for you. You could use Visual Studio or any other C# IDE for that matter. Now, because it's standard C#, nothing very proprietary, the tools out there that we typically use on a C# projects, code analyzers, source control, continuous integration frameworks such as Jenkins and so on, all of that stuff's going to work. You don't need to worry about if it's compatible. And because, again, it's standard, it's going to integrate and play nice with other .NET libraries or other C# code that you have. And That's it. So thank you very much for your patience through this long presentation. And we hope with PowerScript Migrator, we're going to see APIs all over the world.